Hello everyone, this is Amika Mahajan. Welcome to my channel. This video is focused on applications of Gauss law in electrostatics. We will concentrate on field due to an infinitely long straight uniformly charged conductor in case of this video. Basically, what we consider an infinitely long thin straight wire with uniform charge density lambda, this one. Now, what we find, if we take point P away from this wire at a distance r, and this radial vector OP, if it is rotated around this wire, अगर इस radial vector OP को इस wire के around rotate कर दें, तो हमें 3 पॉइंट ले लेते हैं, एक P, एक P डैश और P डबल डैश. ये जो तीनों पॉइंट पे इलेक्ट्रिक फील्ड का जो मैग्नीट्यूड है वो क्या रहेगा, सेम रहेगा. And the direction of electric field at every point must be radially. अब ये आउटवर्ड कब होगा, जब ये लैम्डा ग्रेटर देन 0 हो जाएगा, और ये रेडियली इनवर्ड कब होगा, जब लैम्डा लेस देन 0 हो जाएगा. यानी अगर लैम्डा नेगेटिव है सो इट विल बी रेडियली इनवर्ड, इफ लैम्डा इज ग्रेटर देन 0, और इट इज पॉजिटिव देन इट विल बी रेडियली आउटवर्ड. अब हम क्या करते हैं, दो एलिमेंट ले लेते हैं, जैसे एक P1 ले लिया और एक P2. Now, electric field due to these elements at point P will have two components, one along radial vector and one along normal to this radial vector. इसी तरह से second element की वजह से भी. But we find that components normal to radial vector, they will cancel each other's effect. So net electric field due to these two pair of elements will be along the radial vector. तो हमें क्या मिला कि जो total field है at any point P will be radial. So we get resultant field due to two elements of pair along the radius vector. Now, because this wire is infinite, so field will not depend upon position of P along this wire. This field is everywhere radial in the plane, cutting this wire normally. और इसका जो magnitude है वो किसके ऊपर depend करेगा, R के ऊपर. Now to calculate field due to this infinite long straight uniformly charged wire, we consider a point P at a distance r. तो हम क्या करेंगे, Gaussian surface imagine करेंगे. It will be a cylinder passing through point P. अब हम क्या करते हैं कि इस सिलेंडर के 3 पोर्शन है. This is circular part 1, circular part 2 and curved part 3. To find electric flux due to this cylinder, we apply Gauss law. Flux will be surface integral of electric field along the closed surface. इस सिलेंडर के 3 पार्ट हो गए, 1 upper circular, 2nd lower circular, 3rd one this curved portion. Now what we find, that electric field is everywhere radial. That means flux through these 2 circular parts of cylinder, first and second part, will be 0. कैसे? Because E dot ds will be E ds cos theta. Now, if I take surface ds, the radius vector will be, this area vector will be perpendicular to this surface. And electric field is at 90 degree to this area vector. So cos 90 will be 0. Similarly, here also. But when I take this curved portion, this is the area vector perpendicular to this surface, electric field is also in this direction. So what will be the angle? 0 degree. So E ds cos 0 will be E ds integration. So what we find, that electric flux through the Gaussian surface will be equal to flux through this curved portion of the surface. That means E into S. And what is the area of this curved portion? For this, we cut this cylinder lengthwise and we straight this portion. It will be a rectangle like this, and this length will be circumference 2 pi r, and this will be L. So area of rectangle will be length into breadth, so it will be 2 pi RL. So in place of S, I can write 2 pi RL. So it will be E into 2 pi RL, and according to Gauss law, it should be equal to Q by epsilon naught. What is Q? Q, charge enclosed by this Gaussian surface, that is charge on this wire. We know that lambda is charge density Q by L. So what will be Q? Lambda into L. When I replace this Q by lambda L, L will cancel. And 2 pi R can be taken to other side. It will go to denominator. And what we get equal to lambda by 2 pi R epsilon naught. I can write in vector form. If I multiply this magnitude with the unit vector perpendicular to this wire along the radius vector, let it is n cap. So E vector will be n cap lambda by 2 pi R epsilon naught. So what is n cap? It is radial unit vector in plane normal to wire passing through the point. And this electric field will be outward, radially outward if lambda is positive. And it will be radially inward if lambda is negative. And this relation is true for electric field around the central portion of long wire, where end effects can be ignored. Thanks for watching this video. Like, share, subscribe my channel.